solve some problems on capacitors. So here we have got a parallel plate capacitor of capacitance 5 microfarad. So we have got the value for C, which is 5 microfarad. So micro we have to convert, so we'll write it as 5 times 10 to the power of negative 6 farad. Then it says it's connected to a battery of unknown voltage. That means we don't know what's the voltage, so V is missing. Then it says find the voltage. So we want to find voltage across the capacitor if it stores a charge of 30 microcoulomb. So that's the value for Q, which is equal to 30 microcoulomb. Again we'll convert it, so 30 times 10 to the power of negative 6 coulomb. Now we know the formula for capacitance is C equal Q over delta V, where delta V is the potential difference or the voltage. So we can write this V which I have written here, we can write that as delta V, because delta V means potential difference or the voltage of the battery. So now we can put the values which we have here. So 5 times 10 to the power negative 6, that's the capacitance, equal 30 times 10 to the power of negative 6, that's the value for Q over delta V. So let's just move this a little bit to the side to solve it. Okay. So now we need to solve for delta V. So what I'm going to do is, either you can use calculator directly, or I'm going to arrange the formula because I want to find delta V. So I'm going to write it as 5 times 10 to the power of negative 6. Cross multiplying it, I will multiply it with delta V, which is equal to 30 times 10 to the power of negative 6. Then we want to get delta V alone. So what we'll do, we'll divide both the sides by 5 times 10 to the power of negative 6. Here also we'll write 5 times 10 to the power of negative 6. This will get cancelled out and we'll get delta V. We can solve this using calculator, or you can do mental math. 10 to the power negative 6 will get cancelled out. 30 over 5 will give us 6. 30 over 5 will give us 6 volt. So that's the answer for the first one. Next it says with the battery still connected. So if we want to draw it, so you have got a battery which is connected to a capacitor. So battery's potential difference of voltage we already found, that is 5 volt. It says with the battery still connected, the distance between the plates of the capacitor is doubled. So this distance between the plates of the capacitor, which is D, this D is doubled. So let's write it as 2 times D. It's asking you what happens to the capacitance. So for this we'll look at the second formula for capacitance, which is epsilon A over D, the formula which is based on the geometry of the capacitor. We know that capacitance is equal to epsilon A over D, where A is the area and D is the distance between the plates. Now it's saying if this distance, what is it saying to us? If this distance is made 2 times, that means you double the distance. So what you are doing, the new capacitance, if I want to write the new capacitance, I'll write epsilon A over 2 times D. So what will happen to the capacitance? The new capacitance, you can see that it has got a 2 in denominator. That means the new capacitance is half of the original value. So I can write the new capacitance becomes half of its original value. Okay.